Hey guys, today we will learn about power flow, you know, active and reactive power in the power system. So actually, it's a kind of a coincidence. Actually, as you guys know, I'm also a student, right? So I also learning power system. Also the this power system. They also teach me like power flow, you know. So I will try to do, explain more deeply. Okay. So first of all, yeah, ignore this part. We will learn it later. Okay. And first of all, I wanted to explain you guys. Look at the guys. Mm, yeah. So the result, first of all, we need to know here and here, voltage. The magnitude is related P. P is voltage magnitude, and then this angle, we say, this is Q angle, I say theta. So yeah, so from the big number to the small number, it's flowing, you know. But here's the thing. Here's the V1 and V2, right? So for example, it doesn't matter, the current direction here or this way. It doesn't matter. So here, if it's generator part, and this is motor, like our load. So this is we say Vs sending, sending voltage, and here is a Vr receiving here. So yeah. So we already learned why we conjugated on the I, you know what I mean? Because of our system is generally lagging, right? So first we need to learn about we need to make a voltage equation, right? So V1 equal plus V2 plus I J. Actually, it gotta be plus I plus JX. But what I mean is that in this time, we ignore R. And generally, R is just so small. You know what I mean? So that's why if we do it, want it to R, if we want it to the I, so we could make this, right? V1 times V2. And here's your JX, right? So here we get this I current, right? And then conjugation means it make it the angles, the angles, the zetas angles, to change the forward. You know what I mean? If it's minus to the plus, so if it's plus to minus, we change it to this. So but don't look at that here, okay? Just here is bigger, right? And here is bigger. So which means so which means Q, reactive power. Q is from this number to this number, V2, right? V1. And the angle is, I said, P, active power, right? And also this is higher number, right? P, also V1 to V2. Let's see what happened. So if we using calculator, we could get it, this number. So I want to say is, look at that. Since in the line, there's no R, you know what I mean? Actual loss, active power loss. So it only has reactive power loss. this number from here, and this minus this number. So we lost this number here. Yeah, this is the first equation. And then we need to how to interpret this. So this is this part is sending, right? Sending is a plus, which means I send to you this active power and this reactive power, right? And receiving is also, if it's plus, we will say, oh, I spent this active power and I need to spend this reactive power. You know what I mean? So let's see, what if we change, okay? So if we go to the next page, as you can see here. So look at that. If I change I, direction is here. The difference is, so if we change it to the here, V2 equal V1 plus I, Ji, right? So which means V2 minus V1, right? Ij, I, Ji, J1. J1 is I, same, right? So we get it, this current I, right? So if we calculate this, and we get this number and this number. But compared to previous value, it's different, right? It's a minus, we get it, right? So how we interpret this in this time? We look at that. If we current direction, if we assume current this way, so at this part, this is sending part, right? And this is a receiving part, receiver part, right? So look at that. Sending is a minus, which means if it's sending is a minus, which means it need to be reversed way, right? So which means oh, I spend this active power and I spend this active power, right? It's a reverse thinking, right? And then this is the receiving part, right? Receiving means also I get it, right? But since this is minus and minus, you need to think differently, reverse. So actually this is receiving, but since this is minus, so we think, oh, I make it and then sending to this. And then I, even though I'm receiving part, but this is minus, so which means I'm generate and sending to this part, right? And then, yeah, that's it. And then from here we minus, we would get it. This is here, reactive power loss. You know what I mean? So, just so you guys, memorize this. How, here, voltage magnitude itself is Q related. And this angle is related P. I'll explain why, okay? So don't worry. Okay. So I'll explain here. As you can see here, V1 and V2, right? So this is a lagging, we generally, lagging system, and 90 degrees like this, right? And then we put here, right? So this is a general in daytime's pager, you know what I mean? The sending part is more higher than receiving part voltage, right? And look at that here. You can see this triangle. Okay. this triangle. This is I cosine theta, right? Cosine. And if it's cosine here, it's a sine, right? I sine theta here, right? So look at that. So if we, so actually this is ix cosine and then ix sine, right? But if we multiply x v over x and x delete vi cosine theta, and if we multiply x v over x delete I v sine theta, which means here this part is a q, right? And this part is p, right? So look at that, guys. So here I said here p cosine, right? vi cosine theta. Here is a vi sine theta, this part. But look at that. This is an angle, right? This is torque angle. Later we will learn, okay? Don't worry about it. This is angle, which means, we saw that 100, 0, and here, this angle, both of them means from here. So this part is, P. You know what I mean? The angle is related P, active power. And this number, okay, V2 is here, right? And V1 is here, right? If we count down here, make a line. So V1 is a more higher number than V2, right? So that's why Q is also flowing from V1 to V2, right? And also, yeah, this is P. And Q is also, angle is higher, right? V1. And then V1 to V2. And then, yeah, that's it. Kind of easy, right? But actually, yeah, try to understand it, you know what I mean? It makes, more easier to understand the power system. And the last one thing is, also, I'll give you guys, what happened if we, voltage magnitude is the same, and the only difference is this angle. You know what I mean? Angle is, what did I say to you guys? Angle. Angle is, I said, hey, yo, I will do it. Okay, look at that. Here is a cosine, right? I said angle is here, right? And this and this is P, Q. Q is V is magnitude. And then here, angle is P. So only difference is P, right? So which means P is flowing from here to here, right? And Q is, sorry guys, Q is the same. What happened? So if we, calculate this, and we get this part. But look at that. If the current direction is here, I mean, it doesn't matter if the current direction is here, okay? Just the differences is how we interpret this, the result. So this is the sending part, right? Sending is plus means I sending to you, right? But here is the receiving part, right? Receiving. So which means, oh, this is plus. Active power is I consume, I used it. But look at this is minus, which means even though I receiving part, but I need to sending, right? Like a generator. So actually we get loss, reactive power loss here. So here, I22 multiply Jx. Jx is just 1J, right? Is this number we could get it. So if the voltage is the same, there's only a reactive power loss in the line. You know what I mean? Yeah, that's it, today's lecture. Kind of, you guys can understand easily, right? If we learn and learn. Actually, it's for me also a good thing, to try to make it, to prepare this. If I didn't understand it properly, how could I explain to you guys, right? That's it, today's lecture.